Okay, so I've decided to take a follow-up video for the, logger rate limited problem that I've just shoot this video. So, okay, so I've shown the process that I use the hash map inside of the logger. However, the problem here, the possible optimization here is the space complexity. So in this approach, every message is stored in this hash map. And okay, and the thing is, it is think of the message which is already updated. So in such message doesn't have to remain in the hash map. So that's a possibility of the optimization. So I will think how I can, save this memory, space, save the space with that. So let me think of it. So, okay. So let me think of the case when the message comes in this way. So, okay. So I will think of the message only A. So in this case, I see. Okay, wait a minute. So, okay, so yeah, let me think with this. So in this case, this should be memorized that message A can be available next at time 11. Yeah. However, this message can be ignored. I mean, this event can be ignored because at this time A is available at, yeah, A is available at 11. Then when I get this, I can just ignore it because it's still waiting for the next time. And when I got message 10 in A, I can just ignore it because this is A cannot be loggable yet. Then when I get this event 11, B, this suggests that the current timestamp is 11. So this can be removed. Yeah. Then also I will add this new message B, which should be available at time 21. Then when 12B comes, I can just ignore it because B is still in the hash map. So that being said, what I can use here is hash map, which has message to next possible timestamp. And also I can use the queue probably to store the messages available. Yeah. And TS. So queue is the data structure of first in, first out. So as I said, when I get 1A, this 1A is currently available. So this should update the hash map. And also this should be pushed into the queue. Yeah. So 1A should be here. Okay. Then when I get 2A, I can just ignore it, so I don't have to push it into the queue because 2A isn't rogged, so I don't have to keep it in my mind. Yeah. What matters is the oldest rogged message. And when I get 10A, this can be also ignored because this cannot be rogged. Then when I get 11A, this suggests that the current time is 11. So when I take a look at 1A and I find that this is in the queue, so I can pop it out. And also I can remove this A from the next tiered hash map. Yeah. So that's basic usage of next tiered hash map and queue. So quickly let me write the pseudocode. When loggable, what I mean by loggable is there isn't the message in the hash map or the next TS in, wait a minute. So, okay, so let me, firstly, I will pull out outdated message from queue. This should come first. Yeah, then so pop out message should be removed also from hash map. And that being said, if this is loggable, which means that message in next.ts. Oh, so what I found is actually I don't have to use next.ts as a hash map. I can use the set instead. So, yeah. And here, when loggable, this is loggable. So add it to set and also queue. Yeah. Otherwise, because this isn't loggable, I can just ignore it. Yeah, do nothing. Okay. So okay. So yeah. I can think of the set as the blocked messages, and also queue as the queue is the latest logged message, latest logged time. Yeah. Okay. Okay. So let me think of the complexity analysis. So for the time complexity, this is, so basically I will pop out from the queue, update a message from the queue. So it is possible that I have to pop out all the messages from the queue so far. Just think of the case when the at time 0 many messages like A and B and C and D comes, and after that, when time 11, the method is called again. In that case, I have to invalidate all the outdated message from the queue, so this takes all of n time. And then, oh, after that, in line 70 to 77 to 78, I can find, I can do this in the constant time. Yeah. So time complexity should be O of n. And for space complexity, it is possible that I have to keep track of all the words, all the messages in the queue, set and queue. Yeah, if the messages are different, so it should be O of n in the worst case. Yeah. So yeah. Okay. I will compare these two solutions. The first one with the hash map and the second approach with Q and Z. I will compare them later after I finish the implementation. So let me quickly finish it. So self-blocked last blocked here. So first thing I have to do is invalidate this mess, outdated messages. So as long as there is an element, and also the first one, first element of time. So this is smaller than the current timestamp. Oh, no. Minus 10. So if the current time is 11, I can invalidate the time at 1, 11 minus 10. So if this is the same, I can invalidate. Okay, so in this case, I will pop it out from the queue. Yeah. So now, oh, and also as written in line 75, I have to pop out message should be also set. So I will invalidate it. Then in line 77, so if this message is in unloggables, I will do false. And if this is loggable currently, I will log it, so I will return true. And also I will add it to the set and queue. So so Okay, so this is the thing. Let me quickly check this code. So unloggables is set and Rust log times is deck Q. So and this has the message and TS timestamp tuples. And in line 93, I will invalidate that the message first is a Q. So yeah, if there is an element is a Q and last logged times the first element is the Q. I'm looking at the timestamp of it is smaller or equal to the timestamp minus 10. Yeah, I will pop it out from the queue and I will also remove it from the unloggables set. Okay. Then in line 99, I will handle new messages. Yeah. So in line 100, if this is a set, I will return false. And otherwise, I will log it. So in line 103, this message should be added to the set. And also from this message should be appended to the queue. Yeah. And I should return true. Okay. So one thing I can change is update is in line 95, there is a magic number 10. So I will define it as a constant. Okay. So okay. And okay. So I will run the test codes here again on my next, I mean, new code. Okay, good. So I will run this in the LeetCode platform. Oh. So maybe this is on the, this failed on the, okay, last two elements, 11C and 11A. When I take a look at 11C, my code returned false, but expected true. And when I take a look at the test case, so 11C, for C, it was logged at 0C and 0C. So this should be now outdated because, yeah, 0 plus 10 is 10. So C should be loggable from timestamp 10, but actually it isn't. So, oh, wait a minute. So, oh, my screen is not working. Wait a minute. So, okay. So what I was talking was that 11C should be available because the last event was 0C, which is, yeah, a long time ago. So yes. The thing is that probably 11C has not been popped out from the removed from the set, maybe. Yeah. And okay. That's one assumption from 11C. And when I take a look at 11A, 11A should not be available loggable because 11A exists, yeah, 2 rows before start. So with this 11A, this should be already in the set, but probably not. I will check it. So I will check if the pop out works fine. So mm, so in line 11, I pop out the element, then unloggables remove message, session save unloggables. Yeah, which means so. Let me print out the what inside of the queue and set. Okay. So what I was wondering was 11C. So when 11C is called, C shouldn't be in the set. Yeah. C11. Wait, so this should be popped out from the what do you mean? So for 11C, probably this should be popped out from the okay. So let me print it out after popping out from the queue. Okay, so I found that C. I see. Wait a minute. Why this is C11? C11. Okay, I found the reason. So this is the problem. So in run 12, message here is overwritten. Yeah. So in Python, even though this is message is defined in the scope of while loop, this actually overrides the local, yeah, given argument message. So I will change it to message here. And I will try it again. Sorry. Oh, let me comment this out and run this code again. Okay, good. So I will run this code again. Okay, so the test passed. So yeah, I mean, I implemented the second solution, which uses Q and set. Okay, so from here is the discussion time. So which should be used basically? Yeah. So what I can think is this space optimization approach can be used when the new message comes infrequently, because I have to invalidate each message. So think of the case when the message comes once every 10 seconds. In that case, number of invalidated messages in one, should in one method call is 1. 10 divided by 10 is 1. So for each call, one message is invalidated. So as a result of that amortization, this is acceptable probably. But since 10 million messages comes in 10 seconds, in that case, I have to invalidate 1 million messages in one method call. So probably this isn't acceptable. So yeah, in this case, I shouldn't do it. So yeah, if there is a periods that many messages comes intensively into this logger, I would use approach with hash map. Yeah, and we accept this messages is stored. Every message is stored in the logger. Yeah, which costs more space. However, if the incoming message is infrequent, I will use the space optimized approach. So I will invalidate outdated message every time the method is called. Okay, so the thing. So I will finish, the explanation. Thank you so much. Bye.